All right, so let's check out some techniques for finding limits when direct substitution does not work. So remember, obviously, I'm saying that so you know direct substitution is not going to work on these, but in a testing situation, you're not going to know which it will and which it will not. So I don't want to disregard the point of that you're always going to do direct sub first, because by doing direct sub, that's going to tell you the route to go and your next step. So when you do direct sub, as x approaches 2, of course you get 0 over 0. And now we're going to determine what do we do when we get that indeterminate form. There are 3 possibilities of things that you're going to do. When you see polynomials, like I have here, I mean, it's a rational function, but you have polynomials on the top and the bottom of the fraction, you need to think factoring. And so you're going to take the limit as x approaches 2. You're going to factor the top and bottom. And you're going to notice that something happens every single time. And what that something is of course, that you're going to get a factor to cancel. In fact, the factor that's giving you the 0 over 0. So you kind of guess that that's the factor that is going to go away. And so I'm left with the limit as x approaches 2 of just x plus 2. Now I can do direct sub. I put the 2 in, which I'm guessing you can do that in your head, and you get an answer of 4. All right, let's look at the next one. You try this next one. So the key is, do you remember how to factor the next one? Again, direct sub, 0 over 0. So I'm going to write that every time. But you see polynomials, so let's factor. You have to remember how to factor perfect cubes. And remember, I do a short parentheses and a long parentheses. The dog is sad. In the short parentheses, you think what is being cubed is x, and what is being cubed is 1. In the long parentheses, you do first squared, multiply, so that's 1x, and then square the last. And the signs, remember, were SOAP. Same, opposite, always positive. Once again, this factor cancels with him, and I'm left with the limit. As x approaches 1, I'm left with x squared plus x plus 1. I put in 1's all the way through, and that's an answer of 3. So that's what you do when you have polynomials. And what's happening is, remember, it's the idea of you have a hole that's going on. So this graph, I want to be very clear what's happening so that you understand it. This graph and this graph right here graph the exact same thing except for at one point. They both graph a line of x plus 2. The only difference is in this graph, at 2, you have a hole, and then it just keeps going. And so that's why the limits are the same, because as we know, if I'm asking you about a limit, the limit from the left and the limit from the right, even though there is a hole there, it's still the limit. I mean, your limit from the left and the right are the same. And so you have a limit, and these two functions are resembling the exact same thing except for at that point of 2, but the limits are the same. So that's kind of cool. Let's look at the next case of what you should do. The next case is, I certainly don't see a polynomial, that's square root. Well, the square root's kind of a dead giveaway. With the square root, again, direct sub is going to give me 0 over 0. Let's see, my pen's freaking out, hold on. There we go. Direct sub is 0 over 0. But I don't have polynomials, I have a square root. So here's what we're going to do with him. And again, I want you to be very clear on the notation. I want you to have good notation. I'm not just going to look at your final line. I'm going to see your work as you go through. So I want to make sure that you know exactly what I expect you to write down. And so when you have a square root, you're going to multiply. Again, I can't change what I'm taking the limit of. I can't change the problem. The only thing it's legal for me to do is multiply by 1, because if I multiply by 1 or add 0, but adding 0 doesn't do a whole lot. So multiplying by 1 is what I'm going to do. When I have a square root, you're just going to make the 1 look clever. And what it is you do not change anything outside of the square roots, but you look at this sign. Whatever that sign is, you are going to take the opposite. And if I multiply it on top, I have to multiply to make 1, I have to multiply it on bottom as well. And that's called, the fancy name is called a conjugate. So you're going to take that. And you're going to see why it is smart to multiply by the conjugate. Not really in the denominator. The denominator is just going to stay the same. I mean, you're just going to multiply those two things out, but you're not going to actually distribute. Because let's be honest, we should know what's going to go on. You know that as x goes to 0, this x right here is causing you to have the 0 on the bottom. So it has to cancel out. So multiplying on the bottom would not be smart because you're going to have to factor it back out anyway. You kind of be going in circles. So you learn not to do more work. Now here's why multiplying on top, you can see why this was a smart choice. You're going to FOIL this out. And so you're going to do the first term and the first term, and the square roots are going to go away. So you have x plus 1. Notice that the outside and the inside, that would give me positive square root of 1. The inside would give me negative square root of 1. They're going to cancel, and that was the whole point of being smart and getting rid of that square root. And then the last, I'm going to go minus 1. And so what happens? Well, what happens is the magic occurs. What can I cancel out? Well, this 1 and negative 1 cancel, and then I'm left with the limit as x goes to 0. Notice I have x on top and an x on bottom. So in the next step, I can cancel those x's. So what I'm left with is the limit as x goes to 0 of 1 over the square root of x plus 1 plus 1. And when I have that, I can finish it up. And I just want to make sure, I'm going to say this notationally. All the other ones, I've kind of just written the answer because I've done it in my head. If you are a person that likes to see, get plugging in the 0, that's fine. But I want to be very clear when you do that. If you write this down, your notation needs to be this. When you plug in this 0, you are taking this limit. This is a mathematical operation just like a plus or a multiply. So yes, you have to keep writing this limit as you work. But when you plug in the 0, you are taking the limit, so you don't write it. And then I get down to my final answer, which is, of course, 1/2. But what I'm saying is if you were on a free response and you wrote the limit right here, the limit as x goes to 0, as you plug in the 0, I would take off a point. Because that's when you drop the limit word. When you are plugging in, when you're doing direct sub, you are taking the limit. So I want you to try example 4. See if you can work that one through. Pause the video and work on that guy and come back. Let's see if we got it. Now I like to write it because I want you to, again, to have good notation. So I'm going to take that original. Notice it doesn't matter if the square root is on top or bottom. It doesn't change what I do. I'm going to multiply by the square root of x plus 3 plus 2. Okay, notice I did not change what is in there. And so I'd have x plus 3 plus 2. And let's check out what I would have. So I have the limit as x approaches 1. Okay, this one's a weird one. We learned what to cancel out and what not. Now what we have, we kind of figure that this x minus 1 is going to be canceling out. And again, I didn't do the direct sub, but I think you can see, plug in 1, 0, plug in 1, that's the square root of 4. Okay, 2 minus 2. Okay, I get 0 over 0. So you kind of know what's going to happen. So what's giving you that 0 is, of course, the x minus 1. And that is what is going to need to cancel out. So I kind of clue in that I'm not going to multiply out the top, but I am going to multiply out the bottom. Multiply the first two, I get x plus 3. Multiply the outside and the inside, and there it's going to be a wash, and then I have minus 4. Well, gosh, what do I really have? What do I really have on bottom? If I slap parentheses around that, that's really x minus 1. So, sweetness. I got that to go away. And probably you could plug it in your head. You plug in 1, but just in case you can't, I'm just showing you, again, to reiterate, if I like to see it, I'm going to plug in the 1. I do not write the limit, and I get down to a limit of 4. Perfection. So you kind of get the hang of it as you work, because it's very similar things happen. Okay, they all kind of start looking the same. Okay. Oh boy, fractions. We love fractions, right? Let me do direct sub. All right, plug in 0. That's 1/4 minus 1/4. That's 0 over 0. Okay, so I get indeterminate. What do I do? Well, when you have a compound fraction or a fraction within a fraction, there are several ways to do it. Again, I also like to multiply by 1. But what is 1 going to look like? And man, I tell you, if you can get this step down, this seems to come up a lot, and for some reason people have a hard time with it, but I hope you don't. So let's look at it. I'm going to write this one as a fraction as well. I look at all of the denominators. That's what I look at. I look at every denominator that's written. And what I'm going to multiply by, I'm basically trying to get rid of the complex fraction. So I am going to multiply by the least common denominator of all my denominators. So I just have an x plus 4 and a 4. So I'm going to multiply by 4 times x plus 4 and 4 times x plus 4. Why is that helpful? Well, because on the bottom, I don't really multiply out, because what do we know has to happen? I know that that x is going to has to end up canceling, so I'm not going to multiply anything out. Now watch the beauty of what happens on top. When I distribute this thing to this first term, what I'm doing basically is this: 5 times x minus 2, for example. I get 5x minus 10. That's what I'm doing. I'm just multiplying this times this. Notice when I do that, the x plus 4s would cancel, and I would just get a 4. I would have a minus because of that. Then when I multiply this, I have to multiply the same thing. Although the x plus 4s cancel when I did it to this term, it's both I have to distribute to this term. In this case, the 4s would cancel, and I'm left with, and be careful, parentheses x plus 4. You don't put the parentheses, something bad's going to happen. Now you can fix it, but it's just best that you do it right the first time. I have 4 minus x minus 4. I have 4x over x plus 4. What ends up canceling? Well, I have a 4 minus 4. Now be careful. I have an x and a negative x. So yes, that x and that x could cancel, but man, you better be careful. What do I really have on top? Because if I'm not careful when I do that canceling like that, I would say, okay, great, I've got 1 on top. But remember, you have this negative 1. So you have negative 1 over 4 times x plus 4. When I plug in a 0, then I can now kind of do that in my head, and I get an answer of negative 1/16. Back up here on this line, here's the deal. If you happen to forget the parentheses and you wrote this, okay, you have the 4x, x plus 4, you should know in this line something is not right because you know that this x has to cancel. So when you have 8 plus x, that x doesn't cancel. And it's like, okay, I'm kind of stuck. There's nothing I can do. So again, these problems start looking familiar. You've got to know what's supposed to happen. Oh man, from the beginning, that x is going to have to cancel, so I'm going to do stuff to the top, and eventually I'm going to be able to cancel that x. So if you make an algebraic mistake and things aren't dividing and canceling, then you've made precisely that, an algebraic mistake, and you've got to find where that is. Alrighty, you try example 6. I'm going to erase a little bit so I have a little more room. Alright, let's check this one out. Think about what would be smart to multiply by. What do we got? Scoot him over just a little bit more. Alright, let's look at our denominators. I'm just kind of like in the 4s, I guess. So when I plug in 1, once again, I get 0 over 1/4. And so I'm going to multiply by 1/4 minus 1 over x plus 3. So I am going to multiply by, what are my denominators? My denominators are 4 and x plus 3, so this time I'm going to multiply by 4 times x plus 3. And so when I multiply, what do I end up getting? Should I multiply on top? Nope. I could have put that 4 at the front. That kind of would look a little better. So I have that on top. Now let's do the bottom. Distribute here the x plus 3. And then I distribute here. The x plus 3's cancel. I would have minus 4. And you're almost done. Again, that cancels with that. Boom, boom. I'm really left with the limit as x goes to 1 of 4 times x plus 3. So that's 4 times 4, and I get 16. So what have we figured out? Here's what we figured out. And this is kind of a helpful little piece of the puzzle here. When you start a limit, you're going to do direct sub. And when you do direct sub, the first day, we had this piece. That piece is when you got an okay number, when direct sub works. Now, when is that? Well, that's when you get 7, negative 10. Remember, 0 over non-zero is an okay number. That is 0. So if direct sub you plug in and get that, you are done. You love it when that happens. Today, we discussed what happens when you plug in and you get the indeterminate form. Okay, indeterminate. What do you do then? Well, that kind of had 3 possibilities. If you have a polynomials on top and bottom, okay, then you need to factor. And you have that whole. If you see a square root, you're going to multiply by the conjugate. If you see a compound fraction, then you're going to multiply to get rid of that fraction. Or I'll just say multiply by least common denominator. I'll say it like that. So you're going to multiply by 1. You always know you're multiplying by 1, so you're multiplying on the top and bottom. And then the third case is a case that we will deal with a little bit later. That's way over here. What happens when you get a non-zero over 0? So when you do direct sub and you get 5 over 0 or negative 10 over 0, that's a case that we haven't really talked about, but fear not. We will discuss that tomorrow and then you'll know. All right, so work on that algebra skills, do good work, have good notation, write neatly, because I'll have to read it. So I better be able to read it if it's on your paper. All right, cool deal.